Hello and welcome to the Screencast introducing modeling with exponential functions. Exponential functions of the form f of t equals b raised to the t power exhibit very consistent behavior. They are either always increasing or always decreasing, and they are always concave up. In addition, if we consider how the function's long-term behavior as the input t increases without bound, we find that the output f of t either increases without bound or approaches zero. By considering transformed versions of exponential functions in the form g of t equals ab to the t power plus c, we find that we are able to generate exponential-looking graphs that are potentially concave down and that have long-term behavior where the value of g may approach a fixed value, c. Functions of this form turn out to perfectly model temperature data when the temperature of an object is changing due to the influence of its surroundings. For instance, we will find that for a cup of coffee whose initial temperature is 186 degrees Fahrenheit and that cools to 104 degrees Fahrenheit over 40 minutes time, it can be shown that the function f of t equals 103.503 times 0.974 to the t power plus 71 is a good model for a wide sampling of collected data. In this section, you will learn the effects of the value of a and c on the function g of t equals ab to the t power plus c, how to interpret these values in light of certain consistent function behaviors, and to identify exact values of a and c in certain contexts where other information is known.